All right, here we go, guys. So basically, when we're working for this, we want to find the, oops, make that a little smaller. Uh, we want to factor these things. So we're going to factor this out as x times x minus 1. So I can factor that top one, and that's going to be over. That's going to be over. I'm just going to take a negative out, and we're going to get x squared minus 2x minus 3 because I don't want that negative in front. And so that is going to end up equaling x over x plus 1 equals negative. And then this is going to be what? What multiplies to make 3 negative 3, but adds to make negative 2? X minus 3, x plus 1. So negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2, and that negative just stays out in front. So how do I get these dotted lines right here? I get these dotted lines right there by setting these equal to 0. So x minus 3 equals 0, x equals 3, x plus 1 equals 0, x equals negative 1. So I got two verticals, and that's where negative 1's right here, and positive 3's right there. So this is where my negative 1 is, and then I draw that one there. How do I find my vertical one? Well, I plug in, if you remember, I plug in infinity. So then I pretty much go, let's do a different color. Right here, you can do it either one, but you can just I would just do it right here. You can pretty much say let x equal infinity. And if you plug infinity to all those, infinity, 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 these all cancel themselves out. So you're left with 1 and the negative out in front. So you're going to put that one right here along the axis of negative 1, and that's your horizontal asymptote. So we've got vertical asymptotes, and then from there you just plug in a number. The easiest one to plug in is 0. So you can take this point right here, 0 and 0. I need to do a markup. Hold on, let me do that one. This point right here, 0 and 0, and if you plug it into this equation, you plug in 0 here, 0 here, 0, 0. So you get 0 over negative 3, and that is going to be 0. So that means that this gets drawn here, and then the other two get drawn down there. So same exact thing going on here. We got to factor this piece right here. So let's do that. I'm going to take out a negative 3. If I take out a negative 3, I get x squared plus 3x plus 4. And that's going to be over. I don't like this x right here. That's going to be over an x squared minus 3x minus 4. So I look at this top one, and I get what multiplies together to make 4, but adds to make 3. Negative 3x plus, what do I got here? Oh, this is supposed to be negative. Sorry, guys. Let me change that. I messed up there. I was like, this isn't making sense. We need to get rid of that right there, and we need to get rid of that right there. Okay. Negative, negative. So when I factor out a negative, all these change to negative. So that means I have x plus 1 and x minus 4. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. There we go. And then the bottom one is x over the same thing, x plus 1 and x minus 4. So if I set my, and then at the same time, what we notice here, let's go to highlighting. What we notice is these two are the same. So what happens is if I set that equal to 0, I get x equals -1. And so that means at -1 of my graph, I got a hole in it. That's where that hole comes from. And then let's do a different color here. If I plug this in here, that means that if I set, these are the same, so they cancel out, but I got to account for them. So if I set this equal to 0, x minus 4 equals 0, and that's going to be equal to 4, and that's why there's a dot right here in the graph at 4. So then from there, I still have this last piece. Let's change this color one more time. We'll go to purple. I still have this one here. So I have that one there. That's supposed to be purple. I'm not very good at this, am I? There we go. I'm supposed to be purple. We have that one there. That one's at 0, so that means our vertical asymptote, and I didn't draw it on the straight line. It's supposed to be at 0. That's pretty ugly. That's there. And then how do we find our horizontal? We're going to plug infinity into all of these. So we're going to get -3 over infinity over infinity. And then we'd have 3 infinities on the bottom. And then these infinities cancel out, so I'm left with -3 over infinity. Now, if that's the case, this gets really, really big. So this gets approximately close to 0 because this gets so big, that's small. This is going to get close to 0. So my other one, which I'll do in green, so this one here, that's why. Makes sense now. Let's try this again. This one here is my vertical, so it's going to go straight across the page at 0. That's where that one comes from. And then you can test your a point. Since 0 is right in the middle of the graph where these cross, you can't use it. So you can use 1. 1 is a really easy number to use, so you can use 1 here. And if you plug in 1, you get a negative value. So that means my graph is going to be down here. So you got to plug in numbers for that. So if I plug in 1, you can use your calculator. If I plug in 1 to this and 1 to this, my answer is negative. That means the graph is down here. And if this part of the graph is here, this one is up there. Now remember, this is review, so I'm going through pretty quick. So that's how that one is working. So if we tackle the same thing here, this is a little different because they have this -1 on the outside. So don't forget that this is going to be a over bx minus h, and then this is going to be down 1. So these things, this base graph always looks like this. And we always have vertical asymptotes, and I'll do a highlighter for that. We always have vertical asymptotes at 0, and we have horizontal asymptotes at 0. Now, this here moves our vertical asymptotes either left or right. So H moves it left or right. And then I'm going to do a different color here before I start. And then this one here moves our horizontal asymptote up or down. Okay. So how do we tackle this? So the first thing is since I used yellow, I will use yellow writing, which is kind of be hard to see maybe. Let's see. So I'm going to take this bottom piece and I'm going to set it equal to 0. So x minus 1 equals 0, x equals 1. So x minus 1 equals 0, x equals 1. So I'm going to move this horizontal one to the right 1. And that's why my vertical asymptote right here is at 1. And if you notice, we'll go back up here to this one. Click on that. I have a vertical asymptote right here. This dotted line that goes down like that. And then I have, let's go to red. This one here, just it follows what it sees, so it's going to go move it down 1. So that's why my horizontal is at -1, because it was at 0, and now I'm going to move it down 1, and so my horizontal one is right here at -1 across the page. And what do we know about the base graph? We know that it has a graph that curves like this, and we know it has a graph that curves like that. So that's kind of how you tackle those. All right. So number 4. So this one here, we're going to have to factor. We have this piece right here, which is a divide. So we have to flip this over and multiply. So first thing you got to do is you factor this top one. So this top one up here is going to be 5n minus 4. And this is going to be 5n plus 4. Right there. And then I'm going to factor this bottom one right there. So this is a little different. 5 times, so let's rewrite this down here. I'm going to do 5, not 5. Let me go backwards here real quick. It's going to be n squared plus 18n minus 40. So this one here, I just multiplied 5 times 8 to get this problem here. This is 18 right there. And so what multiplies together to make 40, but adds to make 18? And we're going to do 2 and negative 20. So we're going to do n plus 20 and n minus 2. That's going to be the bottom, but since I multiplied by 5, I have to divide by 5. So this one is divided by 5, and this one is divided by 5. So this becomes n plus 4, and this becomes, and I can move this 5 to the front because it doesn't go into 2 evenly. This becomes 5n minus 2 times, because this is divide, so we're going to multiply it, and we're going to multiply it by this inverse. We're going to flip this over. So I'm going to take out a 3n out of this. So I'm going to get 3n times n plus 1 all over, and then I'm going to factor this top one, which goes on the bottom. I'm going to take a 3n out of that also. So I'm going to do 3n times 5n plus 2. And I just realized something here. Let me fix this here. This I messed up on. This should be 2. So when I split it in half, I messed up here. Gotta make that. Gotta get rid of that. Let me go back to the drawing. This is going to be 5n minus 2 and 5n plus 2. I messed up on that piece because 2 times 2 makes -4. 5n times 5n makes 25n squared. So then my excluded values, and I'm going to highlight these here real quick for you guys. My excluded values, when you want to do excluded values, you're going to take the entire bottom set of values and you're going to set them equal to 0. That's how you find your excluded values. So we're going to have it's funny, they come up with an extra one and I don't get it. And I guess either I did it wrong or I don't think I did, so I'm not worried about that. So we set each one of these equal to 0. The thing that I'm wondering, and n plus 4, The only thing I can think of, and it doesn't make any sense to me, is that this one right here comes from this up here. So they may have accounted for it when it was down here on the bottom, but I don't. That's usually not an option that we tackle that way, so I'm not really sure why it came up there. So again, we take n plus 4, set it equal to 0. That gives us negative 4. We take 3n, we set it equal to 0. It gives us 0. And we set each one of these equal to 0, and it gives us fractions for an answer. So when you find excluded values, just set the denominators equal to 0. How do we get our final answer? We cross out anything that is the same. So let's do a different color here. I'll do green. So 5n minus 2, 5n minus 2, 5n plus 2, 5n plus 2. And then 3n and 3n. So I'm left with n plus 1 over n plus 4, which is what we have right here. All right. Let's tackle this next one here. So I need to add these two together. So the easiest way to do it is multiply m minus 5 times 5. And then multiply m plus 2 times 4, and then multiply your denominators together. That's usually the easiest way to do it. So if we do that, I'm going to come out here, and I'm going to take 5 times m minus 5, and then I'm going to subtract 4 times m plus 2, and that's all going to be over m minus 5. M plus 2. Now what you do on the top is you distribute this in. So I'm going to get 5m minus 5 minus 4m minus 8, because I distributed the 4 in here to these two. And so then therefore I get my 8 there. Then we combine like terms. So 5m minus 4 is m. And then this is 25. Man, my math is bad this morning. 5 times 5 is 25. Negative 25 minus 8 is 33 right there. And then you just keep those two the same. So that's how they get their answer there. So this one here, kind of doing the same idea, except it's multiplication, which is this piece right here. So all we're doing is canceling and factoring. So this top one still stays 10n squared times n, I'll put it in parentheses, minus 6. And this is all going to be over n minus 7. That's a 7. And then I'm going to factor a 3n squared out of this, because I can divide both of these by 3 and both of them by 3n squared. So I get 3n squared. And then if I do that, I get n minus 6. N minus 6. So if I divide both of these by 3n squared, 3n squared by 3n cubed divided by 3n squared, I get an n left over. And if I do 3n squared into 18n squared, I get 6. So when I look at that, I go, oh, looky there. Let me change my colors. N squared and n squared are the same. N minus 6 and n minus 6 are the same. And I get 10 over n minus 7. All right, so let's work our way here. This is the same type of problem, except it's division. So I have to flip this one over on the end and multiply. So we get 9 times b minus 2. I divided by b minus 2 times, and I'm going to factor this. What multiplies to make negative 10, but adds to make 3. And that's going to be b plus 5 times b minus 2. 5 times negative 2 is negative 10. 5 plus 5 minus 2 is plus 3. And over what was on top, which is b plus 5. And then when you do that, you get b squared. B minus 2 is cancel. B plus 5 is cancel. And I'm left with just a 9. That's how they come up with their answer. This one here, if you look at this one right there, that's a division sign. So it's 4 divided by x divided by the fraction 4 over x squared. So since we're dividing, we take this bottom one right here, and we're going to flip it over and multiply. So let's rewrite that real quick. And if we're going to rewrite that real quick, we get 4x, which is the top part right here. So I take 4x and I put it right there, and then I multiply it by this bottom part flipped over, which is x squared over 4. Those cancel, and only one of these cancels. So this one's gone, that one's gone, and then one of those is gone. So my answer is just x. Let's move down to the second one here. If we move down to the second one, basically what happens here is that we just simplify from top to bottom. I can divide both of these by 6. So 24 divided by 6 is 4. And then 18 divided by 6 is 3. P to the fourth divided by P to the third. I have more on top, so I left with the P, so that my answer is 4P over 3, which is that one right there. This is the one, it's kind of just a typical multiple choice question. You have to multiply the bottom and the top by their respective conjugates. So all we're doing is we're taking the bottom and the top and we're multiplying it by the same thing, which is root 2 plus root 3. You have to take the opposite value in here. And this is root 2 plus root 3. So then I get this piece here. And what happens is when I multiply this together, I get 2 root 2 plus 2 root 3. So I just distribute that 2 into each one. And then the bottom, we do that to get rid of the square roots, because root 2 times root 2 is 2. And negative times a positive is a negative. And root 3 times root 3 is 3. And that becomes 2 root 2 minus 2 root 3. And that is all over negative 1. And that negative 1, sorry, this is a plus up there. That negative 1 gets distributed into here and here. So that's why my answer is that one. So the key is using the conjugate, which is the opposite of that one, to multiply the top and the bottom. These are just multiplication pieces. Here, guys, we have, we're just going to take 2 root 10 and multiply it by root 5, and then we're going to take 2 root 10 and multiply it by root 3. So the 2 just stays out front, and you get 2 root 50, because 10 times 5 is root 50, and we're going to add that to 2 times root 30. Okay? So if we took at this and we look at our answers, I've got nothing. The only thing with root 30 is that one. So I'm looking pretty decent, but I need to double check here. So this can become 2 times root 25 times root 2. What's root 25? It's 5. 5 times 2 is 10. 10 times root 2 is the front answer. So that's why they get that piece there. It's just a simplifying piece. This one, you can do the box method with. You can do 5 root 2 and then root 5. And then you can make your box here, your area model like that. And then because it's squared, you're just going to, on the other side, you're going to do 5 root 2 and then root 5. And then you guys are going to multiply in through there, and it'll get you that answer right there. This one here, don't forget you can multiply these two together. Power to a power is multiplication. So we have 64 a to the third over 1 times 4 thirds. And then when you do that, you're going to get, this is going to B, and then you have this one here. Sorry, let me go backwards here. This 4/3 gets distributed into everything. So you can do this in your calculator. 6 to the 64 to the 4/3, and then this is going to be A over 3 to the 1 to the 4/3. And so this is the cube root of 64, which is 3 to the 4th power. So that's how you work this one. The 3 becomes the root, so this is going to be 364, and then that answer is going to the 4th power. You can plug this into the calculator. I know that the cube root of 64 is 4, and then 4 to the 4th power is 256, and then 3 times 4 is 12, 1 times 3 is 3, and that becomes 4. So this becomes A to the 4th power, and that's why the answer is right there. All right, I'm going to get through these next ones on this first video, and then I can't remember how many. So there's 25. So then I'll finish. Actually, I'll stop right there, and then the next video will be the next part. So there we go, guys.